Namaste. In the previous video, we have understood a fundamental concept of SAS criterion of congruent triangles practically, correct? In this session, we shall try to understand the same concept and consolidate all the points we have understood so far with the help of PowerPoint presentation. Shall we start, friends? Here we go. So let us construct a triangle ABC with the following measurements. Base BC 6 centimeter and one of the base angle, that is angle ABC, is 40 degrees. Now we can have two options now here. Among the other two sides, say side BA is given as 4 centimeter or side CA is given as 5 centimeter. So these two construction we shall try to understand simultaneously. So for this we need to draw the base BC, which is equal to 6 centimeter, and with B, with the help of protractor, we have to mark an angle of say 40 degrees. So in both the cases we are showing simultaneously. Join these points. Okay, you call this as ray BP. Okay, so this angle PBC is exactly 40 degrees. Okay, this angle is 40 degrees. Now let us dissolve the protractor and the concerned points. Okay, now observe the case number 1 where BA is given as 4 centimeter. So with the help of compasses, taking radius as 4 centimeter, with B as center, let us cut this ray BP at some point and let this point be called as the point A. Okay. Now, in the second case, with C as center we have to take, because CA is given and radius is equal to 5 centimeter. See, with C as center, with CA is equal to 5 centimeter, we have to cut an arc like this. If you can stop here only, you will get only one triangle. If you can extend this further, see, the same curve is going to intersect this ray BP at one more point. Now the question is, which is the point A? In fact, both are point A only, because both of them are at a distance of 5 centimeter from the point C only. Okay. What are the observations that we can make here, friends? In the first case, two sides and an angle between them are given. See, AB, BC and angle B are given. We say that two sides and an angle between them are given. Whereas in the second case, two sides and not an angle between them are given. They have given us BC, AC and angle B. This is not included between these two sides are given, and in the first case we got only one triangle, and here we got two different triangles which are different in shapes and area for the same measurements. So we can conclude that if two sides and an angle between them are given, then we are going to get one triangle. If two sides and not an included angle between them are given, then we are going to get two triangles. This we saw in the practical presentation. Okay, so now we can see the two triangles shaded. In the second case, see this triangle is so small, whereas this triangle is so big. For the same measurements, we are getting two different triangles. Okay, so now in triangle ABC, measurement of two sides and one angle are given. So angle ABC is called the angle included between the two sides AB and BC. So friends, shall we call this angle ABC as the included angle? So these are the two sides and the angle between them, if it is given, we say that they are given two sides and an included angle are given. Okay. With this note, we can now proceed further. If two sides and an included angle are given, then do we always get one triangle? If two sides and not an included angle are given, then do we always get two triangles? We have to justify now. Previous session we have done the through construction, but in this video we shall try to provide the justification part for these two constructions. So let us try to answer these two questions in detail. Okay, here is a triangle ABC in which two sides and an included angle are given. So how we are going to start? First we draw the line segment BC, which is equal to 6 centimeter. Then at this point B, we keep the protractor. With the help of protractor, we are going to construct this angle 40 degrees. And the ray BP, see, this is called the ray BP, is the only ray that forms an angle of 40 degrees with the line segment BC. So this is the only ray BP that forms an angle of 40 degrees with this line segment BC. Do you know the reason for this? The reason for this is there is exactly one ray that forms an angle of a given measure with the given ray. Okay, this is called as unique ray corollary, which is a corollary to angle measurement postulates. There are postulates are there concerned with the measurement of an angle, and for this postulate, unique ray corollary is one corollary to this postulate, which states that there is exactly one ray that forms an angle of a given measure with the given ray. Okay. Then with B as center and radius equal to 4 centimeter, we cut an arc which is nothing but part of a circle. So with B as center with 4 centimeter radius, with the help of compasses, we cut this. So we are going to get the point A. E is the only point from the point B which is at a distance of 4 centimeter from B. For this also we can give a reason like this. For this we need to recall postulate number 3. Can you recall postulate number 3, friends? There are 5 postulates are there in geometry. Please try to recall them. Okay, the postulate 3 states that given a line segment with one end point as center and the line segment as radius, we can draw a circle, only one circle passing through the other point. So with B as center, with 4 centimeters as radius, if you cut this ray BP, it is going to cut at only one point, because with BP as radius, we can draw only one circle as per the postulate number 3. Okay, once we have done, we can just join C and A in order to get the required triangle ABC. So what is the inference? The inference is, given two sides and an included angle, we are now very sure that one and only one triangle can be obtained. In such a case, we call it as unique triangle. ಅನನ್ಯವಾಗಿರ್ತಕ್ಕಂತಹ ಒಂದೇ ಒಂದು ತ್ರಿಭುಜವನ್ನು ಮಾತ್ರ ರಚಿಸಲು ಸಾಧ್ಯ ಅಂತ ಹೇಳಿ ನಾವು ಈ ರೀತಿ we can give the justification part. Now we'll go to another construction. Base BC is 12 centimeter, angle ABC is 20 degrees, side CA is 4 centimeter. Okay, so this is how we can construct. So we will draw BC is equal to 12 centimeter. With the help of protractor, we draw an angle of 20 degree in order to get this ray BA. Then finally, CA is given as 4 centimeter. So with C as center, 4 centimeters as radius, we cut an arc like this. Okay, instead of just showing an arc, here the full circle has been shown. But remember, observe carefully, this arc is touching this ray BA at this point, at this only one point. It is not at all intersecting, and if you join C and A, you are going to get one and only one triangle. Friends, please note that two sides and not an included angle are given. Please see here, BC, AC measurements are given, and this is not the included angle between these two sides. That we have to note it very carefully. So, if the length of the line segment is such that this AC is such that it is square root of BC square minus AB square. In such a way, if this measurement is given to us, then we can infer that we will get only one triangle. Otherwise, we are going to get two triangles. So, by this, what I mean to say is, if two sides and not an included angle are given, if two sides and not an included angle is given, then also there is a possibility of getting a unique triangle. But if two sides and an included angle is given, we are very sure that we are going to get one and only one triangle, and that is unique triangle. Also note that the BA is the tangent to the circle or to the arc. So this ray is the tangent to this arc or to this circle. Okay, this is a very, very rare and a unique case also. Okay, fine. So please try to remember this. Two sides and an included angle are given. When two sides and not an included angle are given, we can conclude that it is possible to construct a unique triangle. If the angle is not included, then we can have again two subcases, friends. So it may be possible to construct a unique triangle, or it may not be possible to construct a unique triangle. So this is the summary of whatever we have discussed so far. Okay, so let us take a decision now. So ತೀರ್ಮಾನ ಮಾಡೋಣ ಏನಂತ, when two sides and an included angle are given, we can construct one and only one triangle. We call such a triangle as a unique triangle. ಅನನ್ಯವಾದಂತಹ ತ್ರಿಭುಜ, ಏಕಮಾತ್ರ ತ್ರಿಭುಜ ಅಂತ ಎಲ್ಲ ಹೇಳಿ ನಾವು ಇದನ್ನ ತಿಳ್ಕೋಬಹುದು. So okay, so now please observe in the following slide. I mean some other interesting point for you. You can we can be given two sides and an included angle like this. So here AB, BC and angle B is given, or we can also give you two sides, say BC and this side say AC, and you can just join AB in order to get a unique triangle. Or in the third case, they can give us the length of AC as 3 centimeter and the angle A is 90 degrees, and the length of AB can be given as 4 centimeter. Once you join BC, you are going to get a unique triangle. In other words, two sides, any two sides, and if the included angle is given, here AC and BC with angle C is given, here AC, AB and angle A are given. So if two sides and if any two sides and the angle between them are given, then we are bound to get a unique triangle, one and only one triangle, please. So final verdict, when two sides and an included angle are given, we can construct a unique triangle. So this is abbreviated as SAS. Please observe that angle is written in between the two sides. he is saying that the angle is an included angle only. So can we write this SAS as, can we write this as ASS, that is as, or can we write this as SSA, friends? Please think for a while. We have already seen the constructions practically also I have seen. So think for a while. Can we write this SAS criterion as ASS or SSA? That we will once again explore now in the following slides. Okay. So construct triangle ABC with the following measurements. So base is given as 8 centimeter, angle B is given as 50 degrees. So CA is given as 7 centimeter. So with C as center, with 7 centimeters as radius, we have to cut an arc like this. No doubt it will cut this ray at two distinct points. So let us label them as A only. So join C and A. So write this as 7 centimeter. So this CA is also 7 centimeter. So if SSA is given or ASS is given, that is two sides and not an included angle is given, then we may not get a unique triangle like this. So this is what we are trying to understand. So now the same figure I am showing you once again. Now below this, without any arcs, so I am showing you here. So this is the triangle with the 7, 8 and 50. Here also the sides are 7, 8 and 50 degrees. Look, this is so small triangle. This is such a big triangle. It's all because the angle given is not an included angle between the given two sides. So now I would like to share with you another alternate method is there to construct a triangle when two sides and not an included angle are given. This is a very, very interesting case. Let me share it with you now. When two sides and not an included angle are given, so we will first draw the line BC as per the given measurement. So let us call the base as BC and EF. So angle B is say it is about 50 degrees. So let us call this as AB. Here also we will draw an angle of 50 degrees. Call this as D. Okay. Now AB is 6 centimeter and D is also 6 centimeter. So let us join A and C, F and D in order to get a triangle. Okay. Now look at the, concentrate all your attention on the triangle DEF. So before that AC and DF are 4.5 centimeters each. Now D as center, okay, drop a perpendicular like this. Okay, so we'll call this as the point P. Now you try to see the segment PF. Okay, so mark another point on the line segment this EF only. Call this as Q such that QP is equal to PM. In such a way, you choose this point Q on this line EF. Now join D and Q. So what is the length of DQ? It is 4.5 centimeter only. Now let us try to dissolve some of the line segments and try to understand another important point. Okay, so let us try to dissolve all these things. Now observe, friends, carefully the measurements of the two triangles. Here measurements are 6 centimeter, 4.5 and 50. Here also 6 centimeter, 4.5 centimeter and 50. So these are the two triangles having the same measurements of two sides and an angle in them. But this is quite a very small triangle and this is quite a big triangle. So we can construct like this using the properties of isosceles triangles. In other words, if the angle is not an included angle, then we can get two different triangles for the same measurement. So what is the important inference? When two sides and an included angle are given, we are sure to get one and only one triangle. This is true when the included angle is an acute angle or a right angle or an obtuse angle, which we have seen in the previous session. When two sides and an included angle are given, we may or we may not get a unique triangle. So now we will test this. Is this true when the included angle is an acute angle or a right angle or an obtuse angle? So this we are going to test it now. Okay, so this is the segment BC, which is equal to 4 centimeter. In both the cases, say this is 4 centimeter. So let us try to construct an angle of 90 degrees at B in both the figures. Okay, now here the length of say AB is given as 3 centimeter. So here the length of CA is given as 5 centimeter. So we got the point A. So join C and A. In both the cases, you will see that you will get a unique triangle only. Here the angle given is included between these two sides, but here the length of AC is given, so two sides and not an included angle is given to us. So friends, what is that we need to understand? We need to understand the following: angle is and not an included angle. In such a case also, we are going to get a unique triangle only. This is what we should understand now. Okay. Now this is called SAS. Here no doubt angle A is 90 and the two sides are the sides containing the right angle, whereas here ASS are given to an angle and any two sides, other two sides are given. Here the angle is 90 degrees and this side is one of the sides containing the right angle and the another SC is the hypotenuse. So if two sides and not an included angle is given and if the included angle is a right angle, then even in such a case also we are going to get a unique triangle. So this is what we are trying to understand now. Okay. You may be surprised to see that if AB can be extended below and with the C as center with 5 centimeters as radius, if you cut an arc like this, it will cut the line segment AB at one more point. Let us call this point as A dash. So join A dash and C. Now you will see you are going to get the congruent triangles only, and these are unique triangles only. There is absolutely no difference between the shape and size in these two triangles. Let us understand one more important point, that let the given angle be a right angle. So case number 1, if the right angle is an included angle, then we know that unique triangle will be obtained. Case number 2, if the right angle is not an included angle, then also a unique triangle is obtained. So this is what we are trying to understand. Okay. If the given angle is an obtuse angle, so this is the final case. So let us try to understand this. If the given angle is an obtuse angle, then it may be an included angle or it may not be an included angle. In both the cases, we are going to get a unique triangle only. So let us construct this triangles in order to understand this. So base BC is 4 centimeter in both the cases. So here angle B is given say as 100 degrees. Here also angle B is 100 degrees, friends. So with B as center, with 3 centimeters as radius, let us cut this ray. So in order to get the point A, but here let us construct, draw an arc here with C as center and 7 centimeters as radius. Let us cut this ray in order to get the point A. So join the respective points and see that given an obtuse angle, if two sides and an included angle are given, if two sides and not an included angle are given, then observe that in both the cases we are getting unique triangles only. Okay, so if you want, you can extend this AB line below this angle, angle B is 100 degrees. Therefore, definitely this is an adjacent angle of a linear pair. If you extend below, this has to be 80 degrees. So, with 7 centimeters as radius, if you cut this arc below also, you will get the point A dash, and if you join A dash and C, you get some other triangle wherein this triangle is not at all obtuse angle triangle. In other words, this is the only triangle given when two sides and not an included angle are given to us. So this is another very interesting point. So the criterion for congruent triangles, can we conclude like this? There are only three possibilities are there, three criterions are there. So the number one is SAS, the second one is SSS, and the third one is ASA. Under SAS, we can have two sub cases like this. The first being RHS and the second being OSS. What is that we are trying to understand is RHS and OSS are the special cases of the particular cases of the extensions of SAS only, which can be easily proved with the help of SAS and other criterions. So, ಅಭಿನಂದನೆಗಳು ಹಾಗೂ ಅಭಿವಂದನೆಗಳನ್ನ ತಿಳಿಸ್ತಾ ಇದ್ದೀನಿ ಸ್ನೇಹಿತರೆ. ತಾವು ದಯವಿಟ್ಟು ಇದ್ರ ಬಗ್ಗೆ ತಮ್ಮ ಅನಿಸಿಕೆ, ಅಭಿಪ್ರಾಯ ಎಲ್ಲವನ್ನ kindly give me feedback for all these points. Once again, namaste to all of you.